Hi everyone, in this video I'm gonna explain about optical instrument and we will be more focused to lens. So this is the application for lens, for concave and convex lens. The first optical instrument will be eyes. This is the most the most complicated optical instrument, but it uses a lens. So what kind of lens it use? You can see from the image characteristic. You see that the tree become inverted upside down, and the one that can create this kind of image is convex lens. So eyes use a convex lens because you see the image is inverted. What is accommodation of eyes? Well, if you see outside, you see at a far object, you can see the window, for example, you see a tree or sky, and then suddenly you put a smartphone or textbook or a book, anything, in front of your eyes, near your eyes, and then you want to read the text. At first, it will be blurred, right? Because you see very far, and then you see near object. It will be blurred at first, but at a second, it will become clear. That's the ability of eyes to change the focus, or in camera it called as autofocus, the one when you press the shutter half before you capture the image. It's autofocus, it makes the image clear. In eyes it called as accommodation, and this is controlled by a small eye muscle that changes the roundness of eye lens. Okay, I will explain this. It will change the focus of eyes. Okay, like this. For example, we have let's say this is the object, the lamp is the object, and then the lens here is the eyes lens, and the screen here is the retina. So you can imagine that this is eyes, this part. Yeah, this part is eyes, and this is the object. When the object is far, the image is focused here in the retina. But when the object suddenly near, you can see that it's not focused again. The light is not focused in the retina. The goal is to make the light become focused in the retina. Well, of course, we can do this. We can put the screen further, but it's impossible to do in eyes, right? We cannot make our eyes longer. It will be scary to see the eyes of someone suddenly become longer. Going outside from the eye socket, it will be scary, right? So we cannot make the eyes longer. So what should we do? This is what eyes do. From here, it become like this. You can see that the roundness of the lens is changed because eye lens is flexible. It's not made of glass, but it is flexible, so it can change the roundness. And what caused this change of roundness, the thick or the thin of lens? This is changed by the eye muscle. There's eye muscle. There's a small eye muscle that push or pull the eye lens and change the thickness. It means change the focus. If I put it further again, it will become blur again. So the eye muscle will change again, will change the eye lens again, and make a focused image. So because it's a muscle, it means it can be tired, right? If you exercise, you practice basketball, for example, your muscle will be tired. The same thing happen with your eyes. If you look at object that is too clear, too close, it will make the eye muscle must push the eye lens constantly for 1 hour, 2 hour, and of course it will make the eyes tired. Okay, next, I will skip these words. I will skip this. Camera. Camera also the application of lens. The concept is the same with eyes, but for the camera, it use film instead of retina. Well, film is for the analog camera. For now, it's a digital film, right? And then there is also magnifying glass or loupe. It uses convex lens because, well, because concave lens cannot produce a bigger image. The same thing for other optical instrument like microscope. Well, you don't have to memorize all of this. And binocular, sniper rifle, telescope, and then yeah, all of these optical instruments use a convex lens, not a concave, but it is convex. Why it use convex lens? Because concave lens can only produce a smaller image. So if this optical instrument use concave, which make the image become smaller, it will become useless because we want to see a small object, and then this instrument make it smaller. It's useless, right? We want an instrument that can make image bigger, and only convex lens that can produce a bigger image. So this kind of telescope and magnifying glass, they use convex lens. Well, some optical instruments also combine more than one. For example, this one, microscope, it uses at least two lenses, so it can be magnified and magnified again. Some optical instruments like telescope not just use a lens but also use a concave mirror, so it combine lens and mirror. But you don't have to learn this for now. It will be maybe learned in high school, in senior high school, and then you don't have to memorize the year or who found this. It's okay. All you only need to know why it used convex lens, the application. Okay. Okay. So now let's back to the eye. Okay. Now eye will be related with eyeglasses, right? Eye defect minus and plus eye. Minus eye called as myopia, and then hyperopia is the other name for plus eyes, and presbyopia is eyes that um, combination of myopia and hyperopia. It means it cannot see too far, and it also cannot see if the object is too close. Let's start with myopia. Okay, so for myopia, let's go there. Okay, myopia is minus eyes. It means it cannot see object that is too far. For a normal eyes, the far point is infinity. The meaning of far point infinity is it doesn't mean that you can see a very small text in the book of a person 1 kilometer from you. No, no, no. It doesn't mean, or maybe you can see the feather of a bird in the sky. No. Far point infinity, it doesn't mean you can see like a zoom. Your eyes can zoom in like eagle. No, no. Far point infinity means that if the object, even if the object is very far, for example, you want to see moon at night, you see a full moon. Moon is an object that is very far from Earth, right? It's very far, around 1,000 million kilometers from Earth, but we can see it clearly if you have normal eyes. So if you have normal eyes, you can see the moon clearly. That's the meaning of far point infinity. But that's not the case for the myopia eyes. Person with myopia or minus eyes cannot see object that is too far. They can see, but it is blurred. Okay, they can see it, but it's blurred. For example, serious far point is 50 centimeter. It means I cannot. If the object is more than 50, let's say at 60 centimeter or 70 centimeter, I can see the person or I can see the text, but it's blurred. Okay, the maximum distance that I can see it clearly is at 50 centimeter. That is my far point. Okay, for hyperopia or plus eyes, we talk about near point. So near point is the opposite or far point. Near point means the closest we can put the object because plus eyes cannot read object that is too close. Okay. Um, for example, you want to read. For example, the person here. If What is the meaning of at least? At least 25 centimeter means it can be 15 or 20, it's still normal. So here, if you can read textbook at least, for example, you read textbook at 10 centimeter or 15 or 20 centimeter, you can read the book at that distance. That's okay. That's fine. It doesn't mean your eyes is abnormal. No. If you can see, if you can read book um, at 20 or 15, that's normal. That's good. But if you have to put the book at, for example, 40 centimeter to make it clear, then you have a plus eyes. So it in at least 25 centimeter. So at least if a person can read the book clearly without eyeglasses at 25 centimeter, that person is considered normal, have a normal eyes. He doesn't need eyeglasses yet. Okay, so normal point, another point for normal eyes is 25 centimeter. Okay, I will explain a bit about this diagram here. Basically, it means, okay, so this person, let's back to the myopia or minus eyes. The object is far, and then this person with minus eyes cannot see this object clearly, so he need to use the concave lens. The concave lens will create image here. The image here is closer than the original object. It means now this person can see it clearly because this is now at the far point, at the range of the far point of this person. For example, this is 50 centimeter. So this concave lens produce an image at the within the far point of this person. So the eyes will see the image here instead of the object. Okay, so it's like it's trick the eyes. It's trick the eyes. It make eyes think that the object is here near, but actually it's far. So it's like it tricks the eyes. The same thing for the concave lens, the convex lens in hyperopia. The object is near, and the plus eyes person cannot see it because the object is too close. So the convex lens will increase the distance. So this is the image to become further. So now the person eyes will see the image here, which is further than the object. So now you can see it clearly. Okay, so that's the concept. Now for the calculation, power of lens. Usually if you go to optic Melawai, optic says, you will find the measurement of eyeglasses -1, -2. Now in physics class, this is called as power of lens. It has a symbol which is capital P. It has a unit, of course, dioptry, and the formula. Yeah. How to get this power of lens? How do we get this measurement -1, -2, -3? We use the focal length, focus length. For example, the formula is 100 divided by f. The f should be in centimeter. For example, a convex lens with focal length 20 centimeter, we just need to put into the formula 100 divided by 20, we get 5, positive 5. Dioptry, don't forget the unit. And then if it is a concave lens is negative, the focal length is negative, be careful. And the focal length is 50. So the power of lens will be 100 divided by -50, we get -2. It means the person will use -2 eyeglasses. Okay, so that is power of lens. So now the problem is myopia and hyperopia. How they choose the correct eyeglasses, how they choose the correct power of lens. Now this is the formula from the far point. So first you must know the far point of this person. Okay, and this formula will be stated in the daily test, so you don't have to memorize this. but you must know how to use this. For example, oh, okay, this one. A boy with myopia eyes has far point of 200 centimeter. It means this boy cannot see object that is more than 200 centimeter. This is the furthest point, far point, 200. He want to see object that is very far. What is the focal length of power of lens? Which is okay. So the far point, so we get the power of lens here, yeah, power of lens. For myopia, the focal length is equal to minus far point. So the focal length will be minus 200. And the power of lens is 100 divided by f. So 100 divided by minus 200. Or we can just use the formula 100 divided by minus far point. It's the same. So we get minus 0.5 dioptry. So this boy need to use eyeglasses with measurement minus 0.5. Next, for the hyperopia or plus person, this is the formula 100 divided by 25 minus 100 divided by near point. So for plus eyes, hyperopia, we use near point. Okay, if you think this formula, why this formula is so complicated, how do we get this formula? If you want to know, this is basically from this basic formula. Okay, but we want to find out the power, which is power is 100 divided by f, right? It means we want to find out 100 divided by f. But this is only 1. It means I must multiply both sides with 100. So it will become like this, 100. For the other side, also 100. Okay, so we can get the power. Now the power is this. Okay, it looks similar already, right? For the object, why the object is 25? Because as hyperopia person want to read the object, want to read the text or the textbook at a normal position, like a normal person. So you want to put the object at least at 25. This is where the number 25 come from. The position of the book, the position of the object, DO, 25. And then, where is the image? The image should be positioned at the near point, so eyes can see it clearly. So we put the eye as near point. Why negative? Why there is negative here? Because it is virtual, upright. The object should in eyeglasses should be upright. If the eyeglasses create upside down image, inverted image, it will confuse the person that use it, right? So it must be upright, and upright always virtual. Remember, virtual always upright, upright always virtual. So negative because it's virtual. Okay, let's use an example here. This 25. Okay, nah. So a man with hyperopic eyes has near point 60. He want to read at 25. Calculate the power of lens. Well, for the power of lens, we just need to put this. Okay, so we get 100 divided by 25, 4. And the near point is 60 from the question, 60 centimeter. So it will be 1.3. Sorry, 1.6, right? Okay. So we get 2.4. Yeah, positive 2.4. So this pen with hyperopic eyes need to use eyeglasses plus 2.4 dioptry. Okay, so that's how you calculate the power of lens, the power of eyeglasses needed for myopia and hyperopia person. Thank you for listening.